Good afternoon, class. So in today's video, what I'd like to do is my shout out video to chemistry period 5, school year 2025 to 2026. So in this video, I'm going to do number 56 of all the 100 problems that I gave in the chemical reactions homework packets. But if you're breaking it down by assignment, then this would be number 16 in chemical reactions packet 41 through 60. So in this one, we have a double replacement reaction, and we can tell this because we've got the anions over here and over here switch places so that now the sulfate comes to the iron and the bromide goes to the hydrogen. So that's the type of chemical reaction that we have. Now in this one we're going to actually balance the reaction, and I'm going to do that using method number 3. Why method number 3 and not method number 2 like I've gone over in a few other videos? The reason why is because there are ionic compounds in here, and that makes it easier to track whether or not something is balanced. In method number 2, if I just broke this down by putting it on like H2S and then O4, that's fine, and it still works for this method number 3 as well. It's just that if I keep the sulfates together, it gives me a little bit of an extra hint as to what is going to happen. So let's go through this. I'm just taking all of these different compounds here, and I'm just going to write them down vertically to get what I need on the reactant side and on the product side. So we got iron here, we've got bromide over here, bromine 3, got H2 over there, then we've got our sulfate, and this is important. I keep the ionic compound together because that's where I'm going to get my hint. Then we move all the way over here to the product side. We've got Fe2, we've got parentheses SO4 to the 3, and then we've got H and then Br for hydrobromic acid. So now that we have this, let's take a look at the totality of this. Normally, I would suggest looking for the biggest, meanest compound of all of these and say, which one should I leave at coefficient of 1 as our guess. But in this case, I would take a look at this and say, do you see these sulfates? Let's take them and say, let's keep them relatively the same. We're just going to balance the ratio between the two. So I've got 3 sulfates here, so I'm going to guess that I've got 1 for my coefficient over there. And that means, therefore, from this information, I need a 3 over here. And I put the 3 over here because these two, like we see over here, are chemically bonded. So now that I know that, I've got 6 hydrogens on this side, which also tells me that I need 6 hydrogens on this side. So I'll put a 6 here, and that tells me that the bromine is 6 because they are chemically bonded. Because that bromine is 6, I can look over here and say, oh, there's 3 bromines in this one, so I need 2 pairs of bromine, 2 sets of the bromine 3 to get 6 bromines on this side and 6 bromines on this side. Finally, the last step is to, hopefully, if everything balances, the irons will balance last but not least. So 2 times 1 is 2 irons on this side, on the product side, and 2 times 1, 2 irons on the reactant side. So now everything has been balanced, and so therefore when I look towards this one, you would get this, you would have all of these as the coefficients left over for this problem number 16 in problem packet 41 through 60. So I thought I'd point that out as an example and the shout out video. Study hard, see you in the next video.